Hey guys, so there's some quadratics that either don't have a C term or have a B term, or you have something like n squared equals 25. So in order to solve these types of equations, you take the square root of both sides. Okay, now, just like we learned with simplifying radicals, we have to make sure we use a plus and a minus sign for our answer. Read directions to know if you're answering in radical form or decimal form. So the first problem is pretty simple. We're just taking the square root of both sides, and because 25 is a perfect square, that you hopefully do in your head, n equals plus or minus 5. In our middle example, we have x squared equals 72. We're going to answer this one in radical form. So I'm going to take the square root of both sides. Now the square root of 72 breaks down into root 36, root 2. 36 is the largest perfect square that comes out of 72, and 36 times 2 is 72. Therefore, the solution to this equation in radical form is x equals plus or minus 6 root 2. But the directions might also have you answer in decimal form. And if that's the case, you're again just taking the square root of both sides, but you're just going to type it into your calculator. And I get n equals plus or minus 6.4. Sometimes the quadratic is set equal to 0. If the quadratic is set equal to 0, but you notice, hey, there's no b term, so I can't factor this like I normally would, then you can set it up by rearranging this equation like we had on this screen. We can make those problems look like this by adding 40 to both sides, then taking the square root of both sides. Okay, if I answer this in decimal form, I get plus or minus 6.32, just using the calculator. Or if I answer it in radical form, I get plus or minus, plus or minus 2 root 10. Now watch out for this scenario, because this looks like almost the exact same problem as the one that we just did, except it's a plus 40 instead of a minus 40. So let's pretend that we were going to solve this in the same way. All right, we would subtract 40 on each side. We would get x squared equaling a negative 40, but uh-oh, you can't take the square root of a negative number. So this equation has no real solutions. No real solutions. All right, let's look at some more complex radical equations that are quadratic. If I have an equation like m minus 2 squared equals 25, and I want to solve that and know what m is, okay, I'm going to take the square root of both sides. So what that means is square root, square root. Okay? So then it says we'll solve twice using the positive and negative square roots. Well, let me show you what that looks like, what I mean by that. So if I take the square root of both sides, I have m minus 2 on the left-hand side because the square root cancels out the exponent of 2. So just m minus 2. The square root of 25 is both positive 5 and negative 5. So here's what I'm talking about. We have to use the positive and the negative root. Okay, we have to set up an equation where m minus 2 equals the positive 5, and we have to set up an equation where the m minus 2 equals the negative 5. And then we will solve each of these. They do not come out the same, by the way. A lot of students think they're going to come out the same, just opposite signs. If that ever happens, it's a huge coincidence. Okay, so we're going to add 2 to both sides, and one of my solutions is m equals 7. Add 2 to both sides over here, and m equals -3. Let's watch that again. Let's do another one. Okay, so here's our next equation. Square root both sides. So on the left-hand side, I'm going to have 2n plus 3 equaling plus or minus 7, square root of 49. Then I have to split this in half, and I have to solve 2n plus 3 equaling the positive 7, and 2n plus 3 equaling the negative 7. Okay, so on the positive 7, we'll subtract 3 both sides. 2n equals 4. Divide both sides by 2, and n equals 2. So that's one of my solutions, n equals 2. Solving with the negative 7, subtract 3 on each side. 2n equals a -10. Divide both sides by 2, and n equals a -5. So this equation has 2 solutions. Now these first couple problems, these first couple examples, I made them come out nice and pretty to, dip our toes in the water for our procedure, all right? But we're going to have to solve in decimal form, and we're going to have to solve in radical form. So let's do examples of each of those things, because not every equation is going to have perfect squares like 25 and 49. Okay, so on these 2 problems we're going to answer as a decimal, and you can see 298, they are not perfect squares. So here we go, let's get started. Okay, so I'm going to start by taking the square root of both sides. So I get x plus 12 equaling the square root of 200. Since we're answering as a decimal, I can put that into my calculator and get 14 point, let's use hundredths, 14.14, and don't forget, very important, put the plus or minus sign, it's wrong without it. Then we split this into 2 problems. X plus 12 equals the positive 14.14, and x plus 12 equaling the negative 14.14. And then we solve both of those. So x is, one of my solutions is x equals 2.14. And my other solution is x equals negative 26.14. Go ahead and take one more look at that before I move on to the next one. You can pause it. Moving on to the next one. Okay, square root, both sides. 4x minus 5 equals, okay, the square root of 98 is 9.90 if I rounded it to the nearest hundredth. Okay, 9.90. And don't forget, plus or minus. Then I have to split this into 2 parts. 4x minus 5 equaling the positive 9.9, and 4x minus 5 equaling the negative 9.9. and then I have to solve each one of those. So I will add 5 to both sides here. Divide by 4. All right, let's see, 14.9 divided by 4 is 3.725. Okay, then I'll do the other half with the negative 9.9. Divide both sides by 4. Negative 1.225. Okay, so let's look at that one all together. Okay, so now let's look at these same problems but in rational form, or radical form, not rational, radical. All right, this last one, we're going to answer this one in radical form, okay? And the problems that we're going to ask you to solve in radical form do not have a coefficient in front of the x, because that becomes like super complicated, okay? So we're going to square root both sides, all right? X plus 12 equals, now square root of 200, all right, the largest perfect square I can divide out of 200 is 100, and 100 times 2 makes 200. So the simplified form of root 200 is plus or minus 10 root 2. Whoops, ahead of myself. Okay, now I'm going to set up the two sets of equations. X plus 12 equals the positive 10 root 2. Okay, I'll do all of that one first. So if I subtract 12, ten root 2 minus 12, don't type it into your calculator. They are unlike terms. It would be the same thing. I want you to think of 10x minus 12. Could I really subtract or simplify that at all? No, I can't. Okay, so the answer here, we usually put the constant first. So it's subtract 12 above, but if I'm putting that first, it'll be negative 12. And then plus 10 root 2. I can't add them together, not without getting a decimal. And if we're answering in radical form, we have to see radicals. So I know that looks kind of confusing. It looks like, well, I didn't finish the question. I don't have x. I have x equaling a math problem. That doesn't look right. That's as simplified as you can get it in radical form, and you have to just stop there, okay? Then we're going to solve for the negative 10 root 2. Subtract 12. Again, you can't really do it. You're just rewriting it. In that order. Now, what I want you to notice is the answers are essentially the same. X equals minus 12 plus 10 root 2 minus 10 root 2. Okay? All right, guys. Thanks for watching. See you next time.